So we understood that in the resistive circuit, the current is in the same phase uh, with the voltage, right? With the input voltage that you are getting. And we also saw that for inductor case, the current is lagging by 90 degrees, right? Now we will, so this is the thing that we got, right? And then we were talking about, or we were about to talk about the capacitive circuit, right? So we know that what is the voltage in resistive circuit, what is the voltage in inductive circuit, and then let us talk about the voltage in the capacitive circuit, right? Divided by the inductive circuit is this thing, omega L, right? This is what we got. Okay, so now let us talk about, am I, so lagging? Yes, guys. So now let us talk about the capacitive circuit. So in capacitive circuit, what do we have? We have this capacitor, and then this is connected with the AC supply, right? So the voltage supply that we are getting is E naught sine omega t that we have already seen from the generator. So from AC generator, we are getting this. And then we have the capacitor, which has the capacitance C. So what is the voltage of the capacitor? What is the voltage of the capacitor? That is Q by C, right? And we know that how can we get the current, right? How we can get the current from the charge. So Q would be Vc, right? And we know that C is a constant, right? C is a constant, and this is, oh, so Nabil has also joined, right? Yes, hello Nabil, assalamu alaikum. Welcome, sir. Welcome. So we have just started,
Welcome.
and we have just started the capacitive circuit. So in the earlier class, we talked about the resistive circuit, right? And which has the zero phase difference, and then we have this inductive circuit, which has a phase lag of pi by 2. And now we are talking about the capacitive circuit. So voltage of the capacitive circuit is Q by C. And now we know that what is this voltage, that supply that we are getting. So Q is EC. And this Q is E naught and sine omega t. And then this is C, right? So constant is this C. Now I want to get current in the capacitive circuit from charge. So what should I do? I should differentiate both the side with respect to time. So I will differentiate both sides with time. So what I will get dq by dt. This is equal to d by dt of E naught C and then sine omega t. So dq by dt is the desired thing, right? That is the current that we want. And then d by dt of the whole thing. But these two things are a constant. So E naught and C, they are taken outside. And then we have to differentiate sine omega t. So can anybody tell me that what is the differentiation of this function? Anybody interested in telling me the answer? Anybody volunteering for the answer?
Uh,
Yes,
cos omega t dot omega.
absolutely correct. Good. So that would be cos omega t dot omega. So we have applied the chain, right? Good. So then we see that this is E naught omega c and then cos omega t. And then this is I. So we can write this as E naught, and I can write this omega c as 1 over omega c, right? Because ultimately it will go at this place. So this is ultimately E naught omega c, but I'm writing it differently because I want something B by something resistance. That is the current, right? So if I compare this with this one, so I will get the effective reactance or capacitive reactance. So capacitive reactance is what? Capacitive reactance is Xc, and this is 1 over omega. Right? If I compare this with this R. And then cos omega t, I can write it as sine omega t plus pi by 2. Right? So we see that in the case of capacitor, I can write this as I naught and sine omega t plus pi by 2. So this is what the current phase is, and the supply voltage that we have from the generator, from the AC generator, that is E naught sine omega t, right? So we see that current is leading. This is leading by pi by 2, right? So yeah, derivation is not important. I just wanted to recap. You guys have learned this in your 12th standard, right? So this is how we get that the current is leading in the case of capacitor. So what do we have? I will just write the summary. So summary is that in the resistive circuit, I is I naught and sine omega t, right? So phi phase is 0. They are in the same phase. In the case of inductive circuit, and I have to write the reactance also, right? So let me write it as Z. This is simply R. And inductive circuit. For the case of inductive circuit, this is the supply voltage that we are providing, and the current that we are getting is I naught sine omega t minus pi by 2. So this is phase difference is pi by 2. And we have reactance, right? Inductive reactance it is represented as XL, and this is omega L. And then we have capacitive circuit. So in capacitive circuit, what do we have? This is again the supply, and then the current that we are getting is I naught sine omega t plus pi by 2. Again, the phase difference is pi by 2. And then we have the inductive reactance, which is 1 over omega. So this is the result that we get. And now we will combine this, right? So just quickly note down this thing, guys. Quickly note down this thing, and then we will talk about the combination of this circuit. yeah, quickly note down that. Whenever you guys have noted, just give me a sign that you guys have noted. So only this thing you have to remember. No derivation is required. Only these are the things that you have to do. If you remember these things, then you can solve the questions, right? Yeah. So whenever you have noted it down, and these two things will be very crucial in understanding uh, uh, the other things, right? So these two things are very important. Yes, noted everyone. Yes, guys, noted. Okay, good. So now let us understand the combination of the circuit, and that is called the LCR circuit. And this thing is very, very, very important, right? So what do we have? We have this inductor, and then we have this capacitor, and then this resistor. And then it is connected to this AC supply. So this is L, C, and R circuit, and this is the voltage that you are supplying. So to understand this thing, what we do is that we use the phasor diagram, right? So if we draw a phasor diagram, so how we can do that? So let's say we have a phasor. Then we have, and the first thing that we have, let's say the supplied voltage. So this is the supply voltage that we have. And what is this? This is omega t, right? This is the supply voltage. Now is so the current that we are getting is, let's say, this one. And this is what? This is phi, this is V, and this is I. So I is I naught and omega t plus phi, right? And we know that the voltage of resistive circuit, that would be with the same phase as this current, right? And the let's say that this voltage, right? So the inductor or the resistive circuit will have the same phase. So let's say this is also VR, and then we know that the inductor is with how much angle, right? So inductive circuit, the current is lagging behind, right? Current is lagging behind, which means that the voltage would be ahead. So voltage would be ahead for the case of the this thing, right? So this is the inductor, and then we have this thing, which is the capacitor, right? So this is the whole thing, and then we have let's say this is omega t plus 90, or this is minus 90, and then this is omega t plus 90, right? And then we take the overall inductive and this capacitive voltage. So this would be in here. So this would be VL minus VC. And then this is VR, right? So the overall, this thing would be how much? Let me write. So this is VR, right? This is VR. This is VR. And then we take the overall thing, right? So this would be, right? So this would be the resultant of this thing. So this is the resultant, right? And this is how much? So this should be 5, right? We have to. So this is our and this is omega t, and this is plus 5. So we know that this is 5, and this is VC minus VL, and this is VR, right? So this would be how much? This would be V would be how much? V would be this VC minus VL whole square plus this VR square, right? This would be the result, because this is our V, right? This is our V, and this is our VR, and this is our VC minus VL, right? This is our VC minus VL. So this is how we get the overall voltage. Is it clear, guys? Is it clear? So this is the overall voltage. Yeah. This is the overall voltage for the LCR circuit. And we can get the current from it as well, right? So we have to just remember this diagram. So this diagram we have to remember. This is phi, this is V, and this is VR, and then this is VC minus VL. So this is the overall diagram that we are getting. This is phi, this is VC minus VL, this is VR, and then this is your overall voltage. So if we remember this thing, then we can find out everything, right? So then we can find out the overall voltage, and then we can find out the phase angle also. So what would be the phase? Phase is tan phi, and this is VC minus VL by R. Yeah, right. So tan phi is how much? VC minus VL by VR, and we can write cos phi as well. So cos phi will be how much? That would be VR by V. Okay. And now this all these relation are in the voltage form, and we can convert this in the reactance form as well. So we can convert this thing, and we know that what would be Vc. So what would be Vc? Vc is simply I, or we can write it as Xc. And what is Vr? Vr is I, and then this is R. And what is VL? This is I and XL, right? So this is the whole thing. And we can write the overall voltage as I and Z. So we can write the overall voltage as this one. And if we put back all these values in here, so what we will get? So we will get tan phi, this is the phase. Vc is Ixc minus VL is XL divided by IR. We take I common, this is XC minus XL divided by IR. So I cancel, and this is simply XC minus XL by R. Right. So this is one another definition of this phase. So this gives you the phase. And then cos phi, why this cos phi is important? Because cos phi gives you the power factor. So power factor is cos phi, and this is VR, which is IR, and then this is V, which is IZ. So this gets cancel, and cos phi is simply R by Z. And now what is this Z? So what is this Z? So we know that V is equal to root of, let's say, VR square plus VC minus VL whole square. And we can write this thing as IZ, and VR is I square R square. And then from this one I also come, and this is XC minus XL whole square. So I square we can take common, and this would be cancelled, and you will get this. So this is the important quantity. One is in the voltage form, and the other one is the in the this reactance form. So this is what we call impedance, right? So if we have this diagram which is clear, then we can write everything, right? So if we remember this diagram, then we can derive all these things. So you guys quickly note down this thing, and then we will, yeah, then we'll do some questions based on this one. So please note down this thing, guys. And if you guys have any doubts, please tell. You just have to remember this thing. This is very important. And then you have to remember all the. So whenever they will say what is the phase, so phase is calculated using, right. So phase is calculated using tan phi, right? Because phase is phi. So you calculate phase using this thing, or you use this. So if voltage is given, then you use that thing. If reactants are given, so this is how you calculate. Quickly note down this thing, and then we'll talk about together. So only this part is important. If we remember this triangle, then the other things we can just write it down. Quickly note down all these things. So you have to just remember that current is with the same phase as resistive circuit, inductive circuit, voltage is leading, capacitive circuit, voltage is lagging. So this is the only thing that you have to do. And then we can derive all these things. Whenever you guys have noted, please tell. Yes, whenever you guys have noted, please tell. Yeah. Okay. So now let us write, and then we'll do some question, and then this will become right. So the important parameters are what? So we have power factor, which is cos phi, right? And then we write what is the average power. Average power in the LCR circuit, and this is what? So this is written as VRMS, IRMS, and cos phi. So this is how we write all these things, right? So average power is this one, and that is dependent upon this cos phi. So we know that for inductive or capacitive circuit, for inductive or capacitive circuit, phi is 90. So cos phi, that would be cos 90, and that would be 0. Right, so cos phi is 0, then P average for inductive and capacitive circuit, that would be 0. So then it would be called wattless current, right? So then it would be, because the average power of that circuit would be 0, so then it would be called wattless. So these are the things that we have to remember. And there is one more thing, that is the resonance condition. So in resonance condition, you have Xc, this becomes equal to XL. So if Xc becomes XL, then your impedance is what? Impedance is R square plus Xc minus XL whole square. So Xc is equal to XL. So then this is XL minus XL whole square. This will cancel, and you will have only root of R square, which is R. So the for the case of resonance condition, the impedance would be minimum. So this would be the graph of the impedance, right? So impedance would be minimum at resonance condition. This is what we call resonance condition. This is your Z, right? So this is how the Z is varying, and this is called resonance condition. Okay, and then at resonance condition, impedance becomes R. And what is this frequency? So at resonance condition, this is 1 over omega C. This is omega naught L. This is omega naught. So omega naught square becomes LC. So omega naught becomes root. Okay, oh, so that would be 1, right? So that is 1 by LC. because omega naught goes here, L goes here. So omega naught square is 1 over LC, and this is 1 over beta. So this is the resonating frequency, right? So these are the important terminologies for the AC current. So quickly note down these things, and then we'll do 2 to 3 questions, and then we will, yeah, and then we will talk about the transform. So transformer we will talk. And what would be the current? What would be the current for resonating conditions? So current will behave like this. At resonance, current would be, this is your current. So at resonance, this current would be maximum. Your impedance is minimum, this current is maximum at resonance condition. So this is resonance. Yeah, quickly note down this thing, and then we'll talk about the other things, right? Yes, noted, guys. Noted. Yes, noted. Whenever you guys have noted, please tell. Yeah, whenever you guys have noted, please tell. Noted, guys. Noted. Okay, so now let us do some question, and then these things will come. Yes. Find some question. This is the first one. This is the question. An inductor of inductance L A capacitor of capacitance C and a resistor of resistance R are connected in series to an AC source of potential difference V volts. As shown in figure, potential difference across L, C, and R circuit is this one. The amplitude of current flowing through LCR circuit series is 10 root L. The impedance of the current is how much? So I naught is given, right? Amplitude of the current. I naught sine omega t plus phi. So this I naught is given, right? How much is this? That is 10 root 2. This is the amplitude of the current. Now we have to find out the impedance of the current is. So then we can write all these are voltages, right? So we can calculate what is the total voltage. What is V? And remember, all these are RMS values, right? All these are RMS values which are given. So we can calculate what is the overall V. And this would be how much? So this would be VR square plus VC minus VL whole square. So this is how much? VR is 40 square and then VC minus VL. So VC is 10 and minus VL, that is 40. So this would be 40 square and then this is 30 square. So how much is this thing? This is 1600 and then this is 900. So this is 2500. So this is 50. So we know that VRMS is 50 volts. That is the RMS value, right? I naught is given, so we can calculate what is the RMS value. IRMS is how much? That is I naught by root. So this would be how much? That would be 10 root 2 divided by root. So this root 2 will cancel and IRMS is 10. So IRMS is 10, VRMS is 50. So we can calculate the impedance. Impedance is how much? VRMS, that is IRMS into Z. So VRMS is 50, IRMS is 10 and then Z. So Z is how much? 50 by 10, which is 5. So Z is 5. This is the value that we will get, right? Is it clear, guys? So this would be the answer. Is it clear, guys? Okay, so quickly note down this thing and then we will do the other question, right? Remember, yeah, this is very important to note that in AC circuit, only the RMS values of voltage would be given, or current also. So whenever you see the marking, so all those would be RMS values, right? Yeah, but in here it was written that the amplitude of the current. So this is the amplitude, right? Okay, so whenever you guys have noted it down, please tell me and then we'll repeat the question. Yes, whenever you guys have noted step. Noted. Okay, so let us do the next question. Right. Let us take the simple question. So, yeah. Is connected to an when L is removed from the circuit, the phase difference between current and voltage is 5 by 3. Instead, C is circuit. The phase difference is 5 by 3. Then the power factor of the circuit is. Okay, good. So, yeah, this one is another important question. And we already know that what is the power factor. So we know that what is the power factor? Power factor is cos phi, right? Cos phi is R by Z. And then if instead C is removed from the circuit, the phase difference is again pi by 3 between current and voltage. Power factor of the circuit we want to find. So we want to find out what is cos phi, and that is R by Z, right? We know that if we have this thing tan phi, this is how much? That is xc. This is what we know. And let's say what is the case? A series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, right? So let's say we have this circuit, inductor, and then capacitor, and then resistor. So this is the initial case, right? In this initial case, we have some phi that we don't. But now we remove this thing. We remove the inductor. So we remove the inductor, and this becomes simply the RC circuit, right? So then what would be this cos phi? Cos phi is how much? That is R by Z, and Z is how much? Z is simply XC minus XL square plus R square, right? So how much is this thing? So cos phi is pi by 3, right? So this is cos pi by 3, and then R by Z is how much? We have removed this thing. So XC and square plus R square, right? So this is how much? Cos pi by 3 is how much? That is 1 by 2. This is R, and then this is XC square plus R square. So how much is this thing? If we take this thing to this side, and then this becomes 2R. So if we square the whole thing, then this becomes XC square plus r square, and then this becomes 4r square. So how much is this thing? So xc square is 3r square. So xc is root 3r, right? And then the phase difference, if instead C is removed from the circuit, the phase difference is again pi by 3 between the current and the voltage. So then what do we have? So then we have cos again phi, and this is R by Z, and this is how much? So this is cos pi by 3 and R divided by Z. So now Z is XL square plus R square, because XC is 0. We have removed the capacitive circuit. So then again this is 1 by 2, and then this is R divided by XL square plus R square. So again we take this thing in the other side, and then this is 2R. Again we square it, and then the final answer would be root 3R. Right. So then, so XL is root 3R, XC is again root 3R. So what would be the power factor? If we calculate the phase angle, tan phi, this is XC minus XL divided by R. XC is root 3R, XL is root 3R divided by R. This cancels and this becomes 0. So phi is 0. Right, phi is 0, so power factor would be how much? Power factor is cos phi, so that is cos of 0, so that is 1. So that would be the power factor, 1. Is it clear, guys? Is it clear? So we have just calculated what is, yeah, so we have just calculated what is the XL and what is XR. And if we calculate these things, and then we can calculate this tan phi, and then from phase we can calculate the power factors. Quickly note down this thing, guys, and then we'll do the next question. I guess we'll talk about one more question, and then we will start transform. Keynote is note this thing. Yeah, whenever you guys have noted these things. Noted. Okay, so now let us the other question as well. Okay, so this one is right. this one we have, let's do this question, and uh, then we have to do this question. So this is an important question, right? This one is an important question, and with this one we have to understand one important problem. But first, let us do this question. Okay. So we know that what is this value given? Always remember in AC circuit, they will always give you the value of the RMS voltage. So VRMS is 200 volt. 50 hertz is the frequency. So frequency is 50 hertz, and then the RMS value of the current in the circuit is so a 40 microfarad capacitor is connected to this AC supply, right? And then we have this VRMS, and then we have what- this frequency is given, and from this thing, what we can calculate, we have capacitance given, that is 40 microfarad. Remember, this is the circuit. Circuit is only this one. So you have this C, and this is the supply that you have. This is E naught sine omega t. So what would be the only resistance of this thing? What would be that? What would be that, guys? Remember, what is Z? Z is R square plus XC minus XL whole square. We don't have R, so this is 0. We don't have XL, this is 0. So Z is simply XC. This is the impedance, right? We have XC, which is the resistance, and we know that VRMS is IRMS and then Z. So VRMS is given already. IRMS we have to find out. This is the VRMS divided by Z. Z is what? Z is XC. VRMS is 200. XC is how much? We already know that what is X. XC is 1 over omega C. So this will go, omega C will go upstairs. So this would become 200 into omega and C. This is IR, right? So 200 and omega, how omega and nu are related? We know that T is 2 pi by omega. And we reciprocate this thing, so 1 by T is omega by 2 pi. 1 by T is frequency. This is omega by 2 pi. So omega is 2 pi and frequency, right? So frequency is given. So this is 2 pi and frequency is 50. Capacitance is how much? 40 microfarad, that is minus 6. So if we put all these values, so how much we'll get? What is the answer? So they have written in this thing. So this is 5 fours are 20, and then this is 4. So this is 2, 2s are 4. Let's write all the powers in one side. So 2 into 2 into 3.14 into 5 into 4, and then this is 10 to the power minus 6. This is 2, this is 1, this is 1. So plus 4. Right. So how much is this thing? So 5 twos are 10, and then 4 twos are 8. 8 into 10 is 80 into 3.14, and then this is 10 to the power minus 2. So 80 into 3.14 is how much? So that we can write as 8 fours are 32, 8 ones are 8, and then 11, and then 8 threes are 24, and then 25. Right. So this would be, we have to put two decimal places. This is 0. So this is 251 into 10 to the power minus 2. And then this is two decimal places in this side. So this would be 2.512, and then this is ampere, right? So 2.5 ampere. This one would be the answer. Is it clear, guys? Is it clear? If it is clear, then please note it down. And then, with, then, okay, good. So please note it down, guys. The only thing that you guys have to remember is that what is the impedance, what is the voltage, and always remember that this is RMS that is given, and then what is the phase angle, and what is the power factor, and then what is the power average. So if you remember all these things, then you can do all these kind of questions, right? Okay, okay, quickly note down this thing, and then we will do the next question. Yes, whenever you guys have noted, please. Yeah. Please, whenever you guys have noted, please tell me, and then I will talk about that thing, and then I'll also talk about the transformer, right? So transformer I will talk about, and then we do some questions on transformer as well. Okay, noted. So now let us understand what is let us open and short circuit. So the idea of short circuit is that resistance is zero. Resistance is zero, and current passes through the circuit. right? So something like this one. So this is the open circuit. This is the short circuit. There is no resistance and the current is passing through. And then we have open circuit. So in open circuit, resistance is infinity, very high, no current is flowing. Right. So let's say if I draw something like this. So this is an open circuit, right? In this circuit, no current is flowing. So this is open circuit. And this is short circuit. Same thing in LCR circuit. So let's say if we talk about inductive circuit, inductive circuit, and in inductive circuit, what is the resistance? So resistance is, or this is called the reactance, right? So this XL is omega L, right? So if omega is 0, if omega is 0, then XL is 0. If XL is 0, no resistance, then what kind of circuit is this? What kind of circuit is this? Can you guys tell me? Omega is 0 means that there is no frequency, which means that the current is not AC. The current is DC, right? So then what you guys can tell me? Yes, this is DC current, right? Yeah, XL is 0, meaning no resistance. No resistance meaning that this is short circuit. So inductor provides no resistance to the DC current. But let's say if you have omega which is infinity, then XL is also infinity. Then you will have high resistance. Then you will have open circuit, right? So frequency, for high frequency, so for AC circuit, for AC current, inductor will provide very high resistance. So in AC circuit, inductor will try to oppose the flow of AC current. It will provide no resistance to DC current, but it will provide infinite resistance or a high resistance to the AC current. So that is all about inductive circuit. And if you have capacitive circuit, so for capacitive circuit, we have Xc, which is 1 over omega c. So what is this thing? So if you have omega, which is 0, which means that you have DC supply. So Xc would be what? This one, so then you have very high resistance, and then this is the open circuit. And if you have omega, which is very large, that is AC, then XC is 0. So you have no resistance, which means that you have short circuit. So capacitive circuit provides infinite resistance to DC supply, and it provides no resistance to AC supply. So from capacitive circuit, AC current will flow, and from inductive circuit, DC current will flow. So that is the idea, right? If this thing is clear, then please note it down, and then we will do some questions. Please note it down first. So just note down this, and then we will talk about transformers. So please note down this. Yeah, whenever you guys have noted, okay, done. So yeah, now let us understand another topic. Or before we do that, let us quickly do one question, and then I will talk about transform. So let us quickly do one question, and then I will talk about this is an important question, right? So this is the question, right? And what do we have? Figure shows a circuit that contains three identical resistors, 9 ohm, two identical inductors, this, and with EMF 18. The current I through the battery just after the switch is closed. Right, so this is what kind of supply? This is a DC supply. So this is a DC supply, right? Okay. So this is what? This is DC supply, and which means what? W is 0, right? So for DC supply, we have already discussed that what circuit. So for DC supply, Capacitive will be open circuit, and inductor will be a short circuit, right? Inductor will be a short circuit, so this is short circuit, and this one is an open circuit, right? So if I draw the effective diagram of this thing, so what would be the effective diagram? So this is short circuit, means that the current will pass, and then this is again a resistor, and then we have this resistor, and then we have this thing which is short circuited. So this is SC, this is SC, and then we have this circuit. So this circuit is open circuit, which means that no current will pass through this. So the effective diagram is these three resistances, and they are parallel. So what would be the effective resistance? What would be the effective resistance? So effective resistance would be, that would be 1 by R plus 1 by R plus 1 by R. So that is 3 by R. So R effective is R by 3. R is how much? R is 9 by 3. So that is 3 ohm. This is the impedance, which is R. And then we have the EMF, which is 18 volts, right? So we can calculate what is the current. Current is 18 by 3, so that would be 6 ampere. And there are no options in this one, so yeah, there are no options. So there is this question was wrong, right? So yeah, this is the answer to this question. Please quickly note down this thing, and then we will right. Then we'll talk about transform. So quickly note down this thing, guys. Yes, whenever you guys have noted it down, please tell. So this one is also short circuit, right? Yes, noted, guys. Yes, if you guys have noted, still me, and if you guys have any doubt, then yes, guys, noted. So Now let us talk about the transform. Let us talk about what is the transform. So what are the parameters in the transform? Right. We have this. So we have this primary coil, right, and this is connected to some AC supply. And then this is the secondary coil, right? So yeah, you have this thing or something like this thing. So you have a secondary coil, and then this is connected to the load resistance, right? So in the transformer, you have primary coil, and then you have secondary coil. So in the primary coil, you have voltage primary, you have number of turns primary, you have current primary, and then you have power primary, right? In the secondary coil, you have voltage secondary, you have number of turns secondary, you have current which is secondary, you have power secondary. So there is a condition, right? There is a condition. You know that what is the EMF? EMF would be something minus NP d phi by d. And what is the secondary voltage? That would be simply minus NS d phi by d. So if we divide these two things, so Vp by Vs, this is Np by N, right? This is the known result that we have. Now for the transformer, so transformer is 100% efficient, right? So transformer is 100% efficient. Then what is the condition for that? So whatever the power is generating in the primary coil, that would be equal to the power in the second. So this would be Vp IP, that would be equal to Vs IS. So what is the condition? So we will get Vp by Vs. This would be equal to Is by I. So this is the condition that we get for 100% efficient transformer. So now what are the kinds of transformer do we have? So one is step up transform. And what do we mean by that? So step up transformer is that we want to increase the voltage. Increase the voltage. Right. So whatever voltage we are getting in the primary coil, we want to increase this voltage in the secondary coil. So that is what is called the step up transform. So how do we do that? We know that Vp is Vs and this is Np and Ns. So we can write Vs by Vp, that is equal to Ns by N. So I want to increase the voltage in the secondary coil. So if I increase the number of turns in the secondary coil as compared to the primary coil, this would be greater than 1. So Vs would be greater than. So this is what we call the step-up transformer. We increase the number of turns in the secondary coil. Step down is opposite. Step down is opposite, and in this case, Ns is less than Np. So we have Vs which is less than. So voltage is decreased, and this is what you use in the, let's say you have this power station. Power station generates the voltage, and then on the streets you will see these transformers. So those transformers are the step down transformer, right? So let's say you are getting 11,000 or 33,000 volts current, but in your household supply, you get 220 volt supply voltage, right? 220 voltage you get. So that is due to the step down transformer on the streets or on the roads. So those are the transformer they are used to decrease the voltage. But if the transformer is not efficient, so if transformer is not 100% efficient, then you have the efficiency. So this is called the efficiency of the transformer. This is V output divided by V input. So what is this thing? V output is Vs, or this is power output, right? Power output by power input. So this is VIS, and then this is VEI. So this is what. So these are all about the transformers. And yeah, we'll stop here. You guys quickly note it down. And in the next class, I will do modern physics and optics. So this is what we'll do in the next class. You guys quickly note down these things, right? Yeah, quickly note down these. And then you just start from here, primary coil and secondary coil. So that would be, quickly note down these things, and then we'll stop, and then next class we'll start the other chapter. Got disconnected. Who Ali got disconnected? Yeah, Nabil, whenever you have noted it down, tell me, and then we will start.